Hello all, welcome to Soumya's Tech Talks. In today's C programming tutorial, we will discuss about pointers. We'll discuss introduction to pointers, usage, and what are the different operators used, and we also discuss pointer versus reference. We will discuss with some example programs also so that you can easily understand. Let's start. So in general, pointers are like when you if you have any idea about treasure hunt, like there will be a different clues were given. So where using that clues you will reach your treasure. So pointers also like that. So you instead of directly having access to data, so you have the memory addresses. So your clues are memory address, chain of memory address, which will lead to your actual variable or data. Okay. So pointer, you can see here I have a pointer which is pointing to this memory address. So it's not a, here no value is stored. Instead of, it stores a memory address where the actual value is stored. Okay. So P's value is 0x0005, which is a memory address. So where the 100 is stored. So 100 or anything else can be stored. So this is pointer. We'll discuss more. So first thing, where the pointers are used. So pointers are widely used in dynamic memory allocation. Like when you are allocating memory dynamically on heap using malloc, calloc, or in C++ new, these pointers are very helpful. And pointers also used in when you want to pass a large object or array to a function. So you have an array where you have to call a function which do some processing on that array. So instead of passing entire array to the as a function argument, which is not possible most of the times, you can pass pointer to that array to the function so that it can access the array using the pointer. And also you can return, like similar way you can from the function you can create a array which is result of your function, and instead of returning the whole array or whole object, you can also return pointer to it. And there are lot of advantages we'll keep discussing in this tutorials. So first the operators used, let's see what are the operators used for the functions, pointers. So first is the address operator, which is denoted by ampersand. So this operator is used to fetch address of any variable or object. Like for example, you have a integer variable p, you want to know where it is stored in the memory, you can use ampersand p. So using this syntax you can get the address and you can store in any pointer variable. Here let's see, I have a pointer variable. So address, called address, you can name anything. I just for easily understanding I named it as address. So you can have any kind of name. So here this address variable store address of the your variable p. So which is in this memory location it is 0x0002 will be stored. So this is address operator. The another operator is dereference operator, which is denoted by star. Like this is used for dereferencing. Like you have a pointer which is pointing to variable. If you want to access that variable or value of that variable directly, you can use star. You can see example here. I have a variable p and I created a integer pointer called address, which is pointing to p. Here p is 100. So as p is stored in 0x0002, the address variable have the value which is address of p, 0x0002. So if you want to fetch the actual value or variable from the pointer, you just use the star address, means you will get the value of p. So you are accessing p directly using the star. So this is the dereference operator. So we also have arithmetic operators. We can use arithmetic operators like plus, subtracts, addition, and post increment and decrement operators. So mostly we use these operators, arithmetic operators, in case of arrays. So you have an array of multiple elements, many elements. So you will have a pointer to starting of address of the array, the address where the array is started. From there you can traverse to the array, so using these arithmetic operators. So plus means move forward, like if you do p plus 2, the pointer will move move by two objects. Let's say you are at 10, plus 2 will move to 30, the element 30, address of the 30. And minus means it is reverse, backward. Let's say you are at 40, memory address of element 40 of the array. If you do minus 2 or something, you will go to 20, element 20. Increment is just like it is same as addition with 1, so just move one position. Decrement is just backward, moving backward to by one position. You cannot use multiplication, division operators, you should not use, it will give you compile error. And also we should, while applying these operations, arithmetic operations, we should make sure that the resultant address what we get after applying this should be fall inside the array region. Like if you do p plus 100 here, p plus 100 if you do, so the address will be 100 elements from this 10, which is not your array, not fall in your array region, because your array is having only 5 elements. If you do plus 100, it will go to some other memory location. So if you try to access it, either it will give segmentation fault or give some garbage values, unwanted results. So you should be careful while using these arithmetic operations on pointers. Okay. And also there is another operator called arrow operator. So arrow operator is just arrow. So it is used when you have a pointer to structure or something. So to access the structure members, you will use the arrow operator. We will see this with one example also. So now let's discuss what is the difference between pointer and reference. So most of the people confuse. Let's discuss today. So pointer is nothing but you are holding a memory address of any variable or object. So reference is not like reference is nothing but you just creating a alias. So you know aliases, right? Alias is just name referring to same object. It's not a duplicate copy of it, or it don't store the address. It's just alias. So pointer is declared with star. Like if you want to declare a pointer variable, you have to use star. If you want to declare a reference, you have to use ampersand. So int star p equals to ampersand x. So we'll give you here p is a pointer which store address of the x. So similarly I can have a int ref, it's a reference which is x. So means it is alias for x. So whatever you do on reference, same thing will be applied on the x. So both are same, just a alias. So if you want to change value of the variable or object using the pointer, if you can use a dereference operator and then apply some operations on that, then it will reflect on the original value, because it's not a duplicate copy. It is the pointer is pointing to the original object. So when you dereference and change anything, it will reflect the original value. Similarly, reference also same. You do any operations on reference alias variable, so it will be applicable on the original variable. So for pointer you need dereference it. Before using the variable, you have to use dereference. Okay. But in case of reference, it is not required. You can just use like normal variable. So and also you can reassign the pointer. Let's say you have a pointer p, here it is pointing to memory address where x is stored. So similarly you can change it, later point you can this pointer can point to another variable also. You can change it, and also you can assign to null if you don't want to point any which means pointing to nothing. We are not pointing to any memory location. So you can assign to null. just capital letters null. But this is not possible with reference. Once you assign, you cannot reassign it, and also you cannot assign a reference to a null. It will give you compile error. And let's see some examples. So pointer, you can see I have two variables int a, b. So first I created star p, it's a pointer p which is pointing to memory address of a, and I can print, I can dereference, like star p, if I do, it will dereference it. I can access a directly using the pointer. So if you print here, it will print 5 value of a. Similarly, I can change it again. Instead of pointing to memory address of a, I can pointing to memory address of b. If I print, it will print 20 because b is having the value of 20. So here you can dereference using star and then print it. So here pointer, you can change the pointer to any address, so it won't give you any issue. But if you see the reference, you can have a reference to a, so whatever you can print directly, you can access it. So you can change it, you can access it directly. Okay, but if you want to change the reference to make alias to another variable, it will give compiler. Only once you can do that. Okay, let's see how to pointers to array. Let's say if you have a function which accept array pointer and do some manipulation on the array, like printing it. So here I have an array, I just pass array like this and tell how many elements inside this. So you have to pass because this function cannot know how much, means it only knows the starting address of the array, but it don't know how many elements are there. So you have to pass array pointer and element so that you can use it, you can access it, manipulate it, whatever you do here, so that will be reflected on your array. So similarly structures, you can see we can have pointer to a structure, like I have a student structure, I created student s1 structure object, and I created a structure pointer, like how you create integer pointer and everything. You can also do a structure pointer using struct student star ptr. It is a pointer to a structure. So here I assign address of this structure. You cannot assign any integer floating point address. You have, once you, based on the type of the pointer, you should point to same object only. If any other object, it will give you compile error. So here the ptr is structure pointer, so student structure pointer. So you can only point to student structure objects. And this arrow operator, you can see, using arrow operator you can access the structure members like this. Okay, so this is the pointer to structure. Now we'll end here, and in next topics we will discuss more on pointer, like constant pointer, pointer to constant data, multiple pointer, function pointers, and typecasting of pointers we'll discuss. Thank you all. Thanks for watching. Please share this video to your colleagues and friends who are willing to learn advanced C concept. Bye for now.